Hello, fellow Unreal Engine artists, designers and developers. In today's episode, we're going to add side walls to our staircase to provide support for our roof and to stop our players from falling onto the floor below. Let's get straight into it. I know I say this every time, but please make sure you've followed the playlist in the description below so that we're building this structure from the same point. So before we get going on any coding today, let's talk about what we're going to do and how we're going to do it. So what I want to do is create a set of side walls for each staircase section that go up to the ceiling level. And the way I'm going to do this is I'm going to make a copy of the staircase geometry script and call it a side walls geometry script. It's going to iterate through the staircase sections in much the same way. So we'll start off halfway through the staircase or halfway along the staircase and then generate walls to the left and right. And we'll do that for every staircase section. And for the landings, we'll generate a side wall on the corners. So we'll have to do some logic that looks at the staircase before and the staircase after to work out where those walls are. So as I said, the structure is very similar to the staircase. So the easiest way to start this is to copy the staircase geometry script and make the skeleton or the foundation of our side walls geometry script. So let's hop into the content browser, find our tools, and let's open up the GS room stairs that we created last time. And before we copy this, there's one thing I just want to rename. This function that I called XY adjustment, it wasn't a very meaningful name, and I'll probably come back to this in a few months' time and scratch my head as to what this does. So really what this was about is making sure that we moved a location in the right staircase direction. So sometimes it was the X direction, sometimes it was the Y direction. So let's rename this function and we'll call it move location in direction, because that's really what it's doing. Okay, it won't change the way this works. It'll rename it everywhere, so that's fine. And that's all I wanted to do here before I copied it. Okay, and let's now go back in here, the content browser, select this GS room stairs and do Control D for copy. And I'm going to call this GS stair walls and open it up. And let's start off just by getting the structure of this. So let's look at what happens first of all. So it sets a dynamic mesh as it always does in a geometry script. So that's fine. And then we're going to create the initial staircase. So let's rename some of these things. So let's first of all say, instead of create initial staircase, we'll say create initial staircase walls. And this calculate staircase dimensions. So I'm just going to rename this to Initialise staircase. And let's get rid of this setting here. What we'll do is the current staircase, we'll do that in the Initialise. So let's get rid of that and let's connect this here and let's just rename things. So instead of create staircase, we'll call this create staircase walls. And then down here where we're looping through, instead of create landing, we'll call it create landing walls. And so the only other thing I want to do is I want to have a function to update the location as we go through each section. I think in the original one I was doing it in the create staircase walls, but it would be better if we do it separately. So let's create a new function and I'm going to call it update base location. And I'm not going to put anything in it yet. So we're just setting up the structure here. And then at the end of here, what we were doing is we were setting some materials. We'll come and look at that later on. In fact, let's just disconnect that for now and we'll worry about the materials at the end. We may deal with the materials actually in a separate video because I think this is going to be long enough just getting the basic walls done. So I think we'll do another video where we do the walls with override materials that allow you to have different wall materials from the staircase and the roof. Okay, so now we've got that update base location. Let's just drag it in here. So we're going to create the first set of staircase walls, update the location, and then as we create each section here, let's do create landing walls, update base location, and create staircase walls and update base location. So that is our foundation for the structure. Now we need to actually go about starting to create some walls here. So let's look at the first thing I want to do, which is to initialize the staircase. Let's double click on that. And at the moment, it's calculating all of these staircase dimensions. Well, actually, we're not creating any staircases here. So actually, let's just get rid of everything in here. So I'm just going to drag around it and delete. And what I actually want to do is I want to set the first base location here. And I want to set it to be the middle of the first staircase. So we've got a current staircase base vector here, which we use to store our location. Let's actually drag it in with Alt, and that will do a set. So we want to set this. Let's split these pins into their separate values, and the base Y is going to be 0. That's going to be the center point. The Z value is always going to be 0 here because we're always going to have our wall starting from the ground level. The only thing we need to worry about is the X value here. So if we get in our spline wall reference, if we get the staircase length, we want the X position to be halfway up the staircase. And that's because when you're appending boxes, which is what the walls are, you always want the center point. That's where it generates them from. So we need to divide this by 2. Put that in the X position, and that's our initialization complete. We now have the central location of the first set of stairs. So, and as always, compile as you go along and save just in case there's any issues. You can address them early. So come out of this now. We've done our initialized staircase. So let's look at, first of all, creating a wall. So instead of going into the create staircase walls and doing that, because we're going to need a left and a right wall, let's work backwards and just create a function to create a wall, and then we can call that twice for the staircase, and we can call it twice for the landing walls as well. So let's create a new function here. We'll call it create wall. And we're going to need a few parameters for this. We're going to need the direction of the wall. So what I mean by that is we're going to give it a central location. So if, for example, you want the walls for the staircase, you're going to want a wall on the left. This is the first staircase. The first staircase goes in a forward direction. We want a wall on the left side, and we want a wall on the right side. For a wall that goes left, we want a wall on the forward side and a wall on the backward side. So these are all absolute directions. So the first parameter we need in create wall is a wall direction. So we need to know what direction we want this wall to be oriented. And we've got a e-stair direction. Let me just start typing in that. That was our enumerator for the 4 different directions. So that's the first parameter here. Next parameter we need is the center point of the staircase or the landing that we're creating the wall relative to. So let's do another parameter. In fact, let's just do 2 here. And we'll call the first one center X, and that's a float. And then the next one is center Y. And you can spell center the European way, you can spell it the US way. It doesn't make any difference to me. So that's a float as well. And the final thing we need to do is we need to take in the length of the wall. So the staircases will have a wall length that's the same length as the staircase. The landing will have the length of the step width for the generated walls. So we need to have that as a parameter as well. So our final input is going to be wall length. And that is also a float. Okay, so we've got the main inputs here. Now we need to work, I guess, backwards from creating the wall. So to create the wall, we're just going to create a box. So if you right click and do append box, and we will put in our dynamic mesh. That's the target mesh. That's the main mesh that we're creating here. Now let's go through each of these in order. The transform. So if we know the X and Y and the wall direction, we need to convert that into a transform for where this box is going to be. And remember, this is the center of the staircase or the landing. It's not the center of the wall. So we need to move this location in the direction of the wall we want to create. So that's the function that we created and renamed right at the start of this video. Move location in direction. Let's connect it here. And let's just move this over a bit as well. And it takes in the direction that you want to create or move the location. Well, that's the wall direction. So we'll put that in here. So from the center of the stairs or the landing, we want to move out half a step width and half the thickness of the wall. So let's put in, we haven't got a thickness variable yet. So let's add in a wall thickness in the variables. This will be a float value, and I won't make it visible in here because we'll have to pass it from the spline wall system. But if I compile, save, we can set a default value here. So let's set the wall thickness to 20. We can always make that a parameter in the main spline wall system and pass it in. So let's now calculate this adjustment amount. So as I said before, it's the, let's get the spline wall reference. So we need to get the staircase width and divide it by 2. So if we put the wall there, half a step width away, half of it will spill into the staircase. So we need to adjust it by another half of the wall thickness as well, so that the wall butts up to the staircase exactly. So we will then, from the spline wall, we will do, sorry, not from the spline wall, from our wall thickness parameter here that we just created, we will divide that by 2. And then we just need to add these two elements together. So the half step width, half the wall thickness, and that's the amount we want to adjust from the center of the staircase or the center of the landing in the direction of either the left wall, if that's what we're creating, or the right wall, or if we're going in a different direction, the forward wall or the backward wall. And then the other things we need to plug in are the X and Y positions that we're adjusting. So that's the center point of the staircase and landing that we passed in. So with that done, we now have the X and Y's in the right location for the wall. So what we need to do now is we need to make a transformation again to go into this dynamic mesh. So let's just connect these together so we don't forget. And let's add in here a make transform. And split the location pins, and the location Z location is always going to be 0. We're always going to start our walls from the ground level, so we can always leave that. Now we can plug in our adjusted X and Y, which will be adjusted to the actual wall location. We can plug the output into the transform, and we'll do this now just because I don't want it to catch you out later on. It's always going to generate the wall in the same orientation, but we need to rotate it, even though it's in the right center point, we need to rotate it depending on the wall direction. So this wall direction here coming in, if we actually just get it again so we don't have the pins crossing all of this area here, what we can do is we can do a select on this, which will give you different outputs depending on the wall direction. If we split our rotation, the Z rotation, in some cases it's going to be 0, we're not going to rotate it, but if the direction of the wall is forward or backward, so that's if we've actually got a staircase that goes left or right, we want to rotate our wall direction by 90 degrees. So let's just attach the return value to the rotation Z. It will then become a float selection, and we just want to change the forward and backward wall directions to 90 degrees. And so that will then, any walls that are oriented in that way will be rotated correctly. Okay, so we're almost there. Last thing we need to do is just plug in the dimensions for our box. And in order to do that, we need to work out the X dimension. So the X dimension is the length of the wall. So we added that as a parameter. So if you do get wall length, we can plug that in here. The Y dimension is the wall thickness that we created. So we'll plug that in. And finally, the height of the wall is going to be the staircase height from the spline wall, but that will take us to the top of the roof. We actually want it just to go up to the bottom of the roof thickness, so i.e. the top of the ceiling. So what we need to do is grab our spline wall reference, get the staircase height off the spline wall, get the roof thickness, and subtract the roof thickness from the staircase height. Sorry, not divide, subtract. And that will give us the exact point where the ceiling is. And we can plug that into the dimension Z. And everything else should be okay. So now we have a function that will create a wall in the right direction relative to the center point it's given and of a given length. So that's our generic function. We can now compile, close this one down, and we can start to create our staircase walls. And once we've created the staircase walls, we'll do our first test because we've done a lot of coding here without seeing if there's any errors. So let's move on to the create staircase walls. And I suggest, this is the old code that was there for the staircase section. I suggest that you delete everything in here. It's probably easier to start with a clean slate. And you see that the create staircase walls has a staircase direction in here. What we want to do in this is we want to create two walls. We want to create one to the left of the staircase and one to the right of the staircase. So let's start off by searching for our create wall function that we just added, and then we'll add two of these. So I'm going to just put them in twice. I'll put them on top of each other, and let's just connect these. So we want to create a wall to the left of the staircase and then we want to create a wall to the right of the staircase. So first thing is the direction of the wall. Well, we don't want the wall to be the direction that the staircase is going in. We want the wall to be relative to the staircase. So for example, if the staircase is forward, we want the wall directions to be to the left and right. If the staircase direction is left, we want the wall directions to be forward and backward. So in order to calculate that, we need to do a little function. And I'm going to add a new function here. And I'm going to call it convert stair direction to wall directions. So we're going to have one stair direction coming in and two wall directions coming out that are the relative left and right. So let's start here. Let's I'm not going to actually change anything in this. This is literally going to be if this then that. So we can make it a pure function here, and we want to have a couple of outputs for here. So actually one input and two outputs. So the input is going to be stair direction, and that's our old friend the e-stair direction. And then two outputs, also stair directions. We're going to call it left wall direction and right wall direction. So we need to convert from the input stair direction to the left and right wall direction. So we need a couple of select nodes here to do the conversion. So if you drag out from stair direction and do select, and then in your output put it into the left wall direction, and we'll just duplicate this as well because we're going to do one for the right wall as well, and put that underneath here. Again, connect the stair direction as the index and the output to the right wall direction. And then let's just think about each scenario. So for the forward direction, if you've got a forward staircase, you want the stairs to the left and down here to the right. For the right facing staircase, you want the staircases to be forward and backward. For the backward staircases, you want them to be a right and left. So right on the first one and left on the second one. In fact, it could be left and right, doesn't matter. It's going to just do two. And the last one, left, is going to be forward and backward. So let's just put backward here and forward here. So this is going to convert the stair direction to the wall directions that we are moving from the center toward to create. So that's our function done here. Compile and save, and let's close this down and finish off our create staircase walls, and then we can do our first test. So we going to plug the staircase direction into convert stair directions to wall direction. And then we're going to plug the left wall direction into the first create wall. And we're going to plug the right wall direction into the other create wall. So that will be a set of parallel walls. In terms of the location that we're creating the wall from, if you remember, our create wall wants the center of the staircase or landing, which is what we're storing in our current staircase base. So let's bring in that variable, current staircase base. Let's split it out and plug in the X and Y into the center parameters and the X and Y here as well. And then finally, we need the length of the wall. And for the staircase walls, this is simply the same length as the staircase. So let's drag in our spline wall, get staircase length, and plug this into the wall length that we want to create. Compile and save, and we're almost ready to test. The only thing is that we need to connect this to the main spline wall to spawn it when you check a box saying I want sidewalls. So let's go back to our content browser and open up our main BP spline wall. And we just need to add another sequence node here. So we've created the staircase. If you remember, we were looping back after the creation of the staircase to do the roof. We don't need to worry about that with the walls. They're not dependent on anything. So let's just go to the sequence. If you haven't got an extra node here, I've got one left over from last time. Add another pin and then just drag off here down to some empty space and do a branch. And we're going to need to create a new parameter to ask if we want sidewalls or not. So in the staircase variables here, let's duplicate the floating staircase boolean, and let's say sidewalls, and make sure it's boolean and visible. Compile and save. The default will be unchecked, so you'll have to check it if you want sidewalls. And now we can plug that sidewalls into our branch. And if the sidewalls option is checked, then we want to add a child actor component, the one we've just been creating. Go over to the right hand side and select the child actor class, GS stair walls. And we want the transform to be the same transform as the staircase, which is this staircase transform that we created earlier. So let's drag that in here. And so it will start at exactly the same point as the staircase. So let's compile that. Let's put a comment around here and we'll say add staircase walls if requested. Okay, that's been a lot of coding there, but we're ready for the first test. We should now be able to see walls on the side of our first staircase. We haven't iterated through the other staircase sections yet, and we haven't created the landing walls yet, but at least we'll see if we're on the right track. So let's come back to the model here and let's select our spline wall system, go down to the staircase. So we've got this sidewalls level. I'll move that up in a second, but if I click on it, we have the right walls here. So let's have a look. Yeah, we've got the right walls there, but we seem to have a duplicate set of walls as well. So we're halfway right. Let's have a look at the code and see if we can fix this before we move on to the next section. Luckily, it only took me a few seconds to work out the problem. Actually, our code is working exactly as expected. So these two walls that are parallel to the staircase are correct. These two walls are the walls for the next staircase. It's just that we haven't updated the location yet. So when we move the location along, those will be moved to the right location. So you can see if I delete the extra staircases and just have one set of stairs, you can see that we just have one set of side walls and they're going up to where the roof line would be if I put the roof on. So that's all looking good. If you've got any problems, yours doesn't look the same, go back over the last 10 minutes or so of coding. Just make sure you've got everything plugged into the right place. So now let's continue on and add the side walls to the other staircase sections. So let's just add these in now. So let's just add in one that goes to the left and then another one that goes forward. And then once we've updated our code, these should appear in the right place. So let's go back to the geometry script for the stair walls. Let's come all the way out to the event graph. And the next thing we want to do is, I'm not going to worry about the landing walls yet. So actually open up your landing walls section and let's just disconnect anything in there at the moment. We'll come back and do the landing walls once we've got all the staircases working. So disconnect that so it doesn't do anything. All we need to do really is update the base location before we do the next staircase walls. So let's click on update base location. And here what we want to do is we want to take the current base location that we've got. So let's get that. Let's drag it out again with a set. And so if you remember, we're in the center of the staircase at the moment, and we need to move to the halfway of the staircase length to get to the next location. So let's drag out, or let's split these out first and split these here. And we'll need to know what direction we are moving in. So that's our, well, first of all, we'll need to add a parameter to this update base location. And we'll call this stair direction. And it's a type of e-stair direction, which mine is from the last time. And then we'll have to do an adjustment in that direction. So that's our move location in direction function. Make sure it's connected on both sides. Staircase direction goes in here. The adjustment amount that we're going to want to do is the half of the staircase length. So we're always moving half the length of a staircase at any point in time, even from this takes us to the middle of the landing. From the landing to the next staircase going in any direction is half a staircase width. So what we need to do is grab our spline wall reference, get our staircase length, divide by 2 to get half a staircase length, and that is our adjustment amount. And then finally we just need to plug in the x and y values of the current staircase base, and then after they've been adjusted in the right direction by half a staircase length, we will update the staircase base, and that will move it to the correct next location. Compile and save. Let's come back out here and have a look. So the only thing we've got to do is we've got to plug in the stair direction that we're going in. So the first one, we've left it as forward because that was the direction that we did for the first staircase. But now we're going through this loop of stairs. We need to get these directions here. So from the array element, we need to plug this into the stair directions. So each of these updating the location, creating the staircase walls, and base location is in the right direction that we've chosen. Okay, landing wall's not doing anything yet, but everything else should work. So let's compile and save, come back here, and it's almost correct. You can see that we've got 3 sets of walls. We've got them here, we've got them in the right orientation here, we've got them right orientation there. They just haven't moved enough. Can you see that they seem to be half a width out? And actually that's because my calculation was wrong. If I'm in the center here, if I move half a staircase length, that takes me to there. I need to also add half a step width on as well in order to get it into the center point. So that was my mistake. So that's easily remedied. Let's go back to the script, open this update base location again, and we'll simply, from the spline wall, we'll get the staircase width as well. And divide that by 2 to get, half the staircase width. Add these 2 together, plus, let's move it back so it doesn't cross these wires. And then finally, the addition of the half staircase length and half staircase width is what we want to adjust by. And fingers crossed, if we compile and save, that looks good. So we now have our walls adjoining our staircase sections, And we can move on and do the last part of the walls, which is the side walls for the landings. All right, before we create our landing walls, let's again talk about how we're going to do this. So if you have a landing and you want to generate the walls, you need to know the direction of the staircase coming into the landing and the direction of staircase leaving the landing. So as by example, if I create a new staircase here, if you have the directions that are the same, so you have forward and forward, then you want to generate parallel walls. So forward and backward are going to have walls on the left and to the left and right. And similarly, if you have, let's do one to the left and then do another one to the left. So if you have left to going to left or right going to right, again you want parallel walls going, in this case on the left you want them at the forward and backward position, same for the right to right. So if the directions are the same, you want parallel walls. If the, let's delete one here, if the walls turn a corner, then you want the walls for the landing to be opposite the direction that it's coming from. So if it's coming from if it's going forward, then you want it to be, well, you want it to be forward on the up side, and then you want it to be opposite on the leaving wall. So forward should have a forward wall, left should have a right wall. And if we turn to the right, then the forward section will have a forward wall and the right section will have a left wall. So we just need to put in a function that calculates the walls based on those rules, and then we can generate the wall using our create wall function, just passing in all of the right parameters, the direction we want the wall generated in and the length of the wall, which will always be a step width. So that's our strategy. Let's just reset this to left and forward. So we've got a test set of stairs for when we update everything. And now let's hop back into the code and do the final updates for the landing. So back into our stair walls, let's just come out to the stair graph, the event graph, and go into create landing walls. And what we'll actually do here is we'll delete, I basically disconnected this, but let's delete everything that's in there at the moment. This was all about creating the landing platform. And first thing we want to do is we want to have an input parameter for this, saying what staircase we're dealing with. What's the stair index? So which stair section are we looking at? So we need to add an input here, and this will be the stair index. And the type will be an integer. And let's just go back to the event graph and just hook that up so we don't forget. So we're looping through each set of stairs. Let's take that array index and plug it into the stair index here. Right, now back in the create landing function, we need to take that index and use it to get the stair direction. So for each two sets of staircases, if you do, actually let's just do this another way around. Let's get our spline wall reference. Let's get our array of stairs, get more stairs. And if from here, if you do get a copy, and then with that selected, duplicate it, we want to get the staircase before the landing, and we want to get the staircase that is going from the landing. So we'll drag this one into the bottom, and we'll also drag here and do a -1 to get the one before. So -1 to get the staircase that came before it. And again, I'm just trying to tidy things up as I go. And that gives us stair directions going into the landing and stair directions coming out of the landing. And you might think to yourself, well, hang on a second. If I'm on the first element here, the one before it doesn't exist. Don't I need to put in some code here to say that will be a forward direction? Well, as long as your default stair index is forward, which it will be by default, then you should be fine. So you might want to put a comment to the effect of the default is forward. So it doesn't need any extra logic, but that's just a fortuitous sort of side effect of that being the first element in our enumerator list and the default value. So let's just comment as we go along here. So I'm going to, around here, I'm going to put a comment that says get stair directions before and after. Okay, so now we've got two variables here. Next thing we need to do is we need to go from the, we convert from the stair directions to the wall directions we want to create. So remember, this is the where we need to put a little bit of logic in here. So we really need a function for this. So let's add a new function over here. I'm going to call this function convert stair turning to wall directions. It's kind of a long name, but it does explain what we're doing here. And what we'll do here is we need two inputs. And the first one is stair direction before, and that is E stair direction. And then we want stair direction after, also E stair direction. And then the output from here is going to be two wall directions. So we'll just call them wall direction 1 and wall direction 2. So those are the two side walls that we want to create on the landing. And now we just need to do a little bit of checking in between. So as I said, there's really two scenarios. One is where the two versions are equal, the direction before and direction after, and that's parallel walls. And the other one is where they go to the left or the right of each other. So we're not going to worry ourselves with going back on ourselves, because that will never work in real life anyway. So you can't go forwards and backwards or left and then right. It just goes over the staircase. So we're not going to worry about those. So let's first of all check if these two are equal to each other. So do an equals, and you want equal enum, and then join the other one. So if the direction before and the direction after are equals, we're dealing with parallel walls, and we can do a branch here with B. And connect this. So if they're parallel, we're going to create a select for the before. In fact, the easiest thing to do is, rather than drag out here, what we'll do is we will get that stair direction before here, and then drag that into a select component. I like to put them on top of each other, and then let's duplicate this, but we'll delete the stair direction before, get stair direction after, and then we'll plug that into the index value. Okay, and so this is going to be our set of translations for if the before and after are equal. So let's just drag this into the wall direction 1 and the wall direction 2, and probably should have done that before I copied them. So taking up a bit of space here, Okay, so let's think what we need to do here. So if the directions are forward and forward, then we want the walls on the left and right. So let's put left on the top forward and right on the bottom forward. If we're going to the right, we want the walls to be on the backward and forward direction. So backward and right is already forward here. If it's backward and backward, we want them to be on the left and right again. So let's just do left here under this backward right. And then finally, if we're going left left, we want the walls to be backward and forward in relation. So that's forward as well. So that is done now. Let's again move it up here slightly. And then all we need to do is let's move the return node up here and connect the true. So that's where these are equal. So now we just need to do the set of conditions for where they're going at an angle to each other rather than parallel to each other. So let's duplicate this return node and just move it down here. And we can now take these two elements here, the before and after selections, do a Control C, do a Control V down here. And the logic here is going to be the direction before is going to be the same as the wall direction. So if you've got a forward going to the left, you want the forward wall as well. So if you've got a right wall then going one direction, you want the right wall as the first wall. So these are all going to be the same, backward and left. And then for the stairs that are leaving the landing, you want the wall on the opposite side. So forward is going to need a backward wall, right is going to need a left wall, backward is going to need a forward wall, and left is going to need a right wall. And then we can drag from the false here. So these are now non-parallel staircases, and we can connect the wall directions here. So again, you might need to pause here and just make sure these are all connected correctly, but this should cater for all combinations of wall directions coming in and wall directions coming out. So compile and save. Let's close this down, and we'll come back to the create landing walls and we'll finish this off. So we've got our staircase directions coming in. That's the minus one here is the before, and the one here is the staircase after. So if we drag out here and do convert and use that new function that we just created. Oh, by the way, we can make it a pure function as well because we're not changing anything. So go back to the function here and select pure and close it down. So we can put the stair direction before in, put the other one into direction after, and that gives us the wall directions that we want to create walls for. And then all we need to do is we need to create the walls. So let's type in our create wall function, and let's duplicate it, and I'll just stack them on top of each other. So our wall direction, which we've calculated here, we can plug into the wall directions of the two walls that we're creating, and then we just need to set up the in fact we need to connect it to, we haven't done any actual execution yet, everything's been getting data or pure function. So from the beginning execution pin here, you need to drag all the way over to the create wall, and then make sure that this create wall is connected to the other create wall. Okay, and in terms of the positions, we are going to be using our current staircase base as the root point. So drag that in, split the axes out, and plug the X and Y position into the X and Y of the create wall. So this current staircase base will be in the middle of the landing. So we've given it the location that we want to create from. The wall direction, it will then move it by half a step width in that direction. So it'll go on the right corner. And final thing we need to put in is the wall length. And the length for the landing walls is going to be exactly 1 step width, because we've made them a square landing that meets at the top of the stairs and starts the next set of stairs. So that's easy to put in. Grab the spline wall reference again, get the staircase width, and plug that in to the wall length. So I'm going to just put a little bit of a comment around this as well. So I'm going to say create walls on 2 sides of landing. And let's compile and save and see if this works. We've got an error somewhere along the line here. Yeah, somewhere along the line I forgot to connect the more stairs array to this get. So you might not have done that. So compile. Okay, that looks okay. Save. And let's keep our fingers crossed. It's kind of almost there. So let's have a look. And I think I know why this is, because we've got one other thing to do. So we've got the right walls here. So for the first set of stairs, we've got the wall on the front and back. For this one, we've got one of the walls, but the other wall isn't correct. So give me a moment, I'll have a look and see if I can figure out the problem, and then we'll fix it together. Okay, and I've found the issue. I just misset one of the selections. So in the convert stair turning to wall directions, in the one below the branch where the direction is at an angle, I set the left to backward, and that left should have been set to left. So all these ones here should be the same: forward, forward, right, right, backward, backward, left, left. And all of the ones here should be the opposite direction. So that was it. It was just simply, it was executing this and generating a wall in the wrong place. So let's compile and save, and everything should be good. So you can see now that the walls are all being generated in the right place. And you could try out some different combinations here. So we could go to the, let's try, go to the right here and forward. And even though it goes out of the room, it still looks as though the walls are being generated in the right place. Again, I'll leave you to try different combinations. It should all work successfully. And let's just also put a roof on here and see what it actually looks like with the roof on. So go back to the spline wall. We're on the spline wall here. Go up to the roof, do create roof. Okay, so we've got roof, and you can see now how much better it looks. The walls go abreast of the staircases, but they go up to the ceiling line, and look, that looks more like a real room would. So if we go into play mode here, and let's find the start of that. So we got stair walls here. That looks all good. Can't remember whether there's collision on here or not. No. So at the moment we've got collision on the staircase, but we haven't got collision on the side walls. So let's just quickly fix that. That's the last thing to do. Should be pretty easy. And I haven't tested it with multiple staircase sections either. Again, it should be fine. I'll leave you to test that. You can always let me know in the comments if there's a problem, but I have tested it out myself and it did work for me, so should be fine. So let's do a quick save of where we are. Let's go back to the stair walls, and let's just look at the event graph. So I'm going to shut down everything except the event graph. I have got collision somewhere, yeah, but I just haven't connected it. So what I could do is just connect this last pin that I disconnected. Let's connect it to here. So this is using, we'll leave this at the moment, but when we do the materials in the next episode, I'm using the staircase UV scale to set up the UVs, but and the material is going to be the material from the wall mesh. I then apply a self union to join all the elements together. That should be fine as well for this, where the walls will become one mesh. And then finally, I'm setting the complex collision. What I do want to remove is this callback to construct roof. I don't want to construct roof after I've done the side walls. I've already done that from the staircase. So make sure you get rid of that. Compile and save. Okay, and you can see that now, because it's set the material, it's set it to the brick wall here. Now, let's test this out. Now, this may not, the collisions may not be working. I'll explain why. Might get lucky. I found just, it's a little, what I consider a little feature of Unreal Engine. Yeah, it's still not working. What I've noticed is that it needs, when you set up that collision for a new script, it needs to, the project sometimes needs to be reset for it to work. So I'll quickly just save and restart the project, and we'll see if that's then working. I'm not sure why that's the case, but that's just something I've noticed. So I'll come back in a moment and we'll see if it's working. All right, I've restarted the project, and sure enough, now if I run up to a wall here, I collide with it. So I can't now walk out of the side of my staircases now. So this is looking pretty good. I said I would add materials, but I think this has been quite a long video here, so I'll do that in the next video. So what we're going to do in the next one is we're going to add material overrides to the roof, staircase and sidewalls, so that if you don't specify anything, it will inherit the wall mesh material like it is here. But if you do specify a material override, it will apply that, so you can have different materials on your different elements of your building. So stay tuned for that one, and I'll see you in the next one. Bye for now.